And welcome back. Now, last week we had a very brief look at the volume control there at the back, the motorized volume control, which is still working well. I'm using it. I'm still thinking about what I'm going to do with it. I showed you very briefly a picture. Yes, and no more than a picture of this little preamp, valve preamp. Yeah, nice. And we'll talk about that some other time, but not now, because it's not really Arduino related, or indeed anything related, is it? It's just an audio preamp. So we'll leave that for another time. But there is this little device here that I bought pretty much at the same time as I bought that one at the back there. I don't know whether the cookies on my PC are very tuned to what I'm looking for. Anyway, that's a volume control, and so's this. And I actually bought it from Amazon because it's a USB volume control. And I thought, well, that sounds like what I was looking for originally before I even bought that one at the back. So I thought, do you know what? I know it's a lot of money. Well, comparatively a lot of money. It's 20 quid. So that's what, I don't know what it is in dollars anymore. The exchange rate is so up and down. It's probably about $30. I don't know, something like that. No, it can't be. $25. And what it is, it's this nice little metal unit with a huge big volume control knob on the front. Comes with a detachable micro USB cable, and this cable's very nice. It's the woven type, and it's very long as well. So the idea is you plug that into your PC or laptop and then just have this sitting on your desk, and you can, well, adjust the volume of your Windows PC. Look, now I know last week I said I was going to give you a demo for this one, and I forgot all about it, and I didn't quite know how to do it because I didn't have any royalty-free music to hand. But this time I've downloaded a couple from YouTube, so I'll be all right. And yeah, before you ask, I have done no further work on my smartphone charger. I know I said I was going to create a PCB, but I haven't got there yet. But talking of PCBs, I want to give a shout out to PCB Way, PCB Prototype the easy way. Just enter the dimensions of your PCB, choose the number of PCBs you want and the layers, and hit the Quote Now button. Now, it's all very well for me to promote PCB Way, but look at these two boards. Now, these are two of many that PCB have made for me. This is quite a simple one, and this is a bit more complicated. In fact, this is an assembled PCB Way board. Let's look at these under the microscope to look at the quality of these products. So here I'm looking for the quality of the drill and pad placement, and as you can see here, it's totally 100% accurate. We have a track coming down the middle, there's the hole, and the pad around it, the soldered pad, is exactly where it should be. And this is replicated throughout the entire board. It's absolutely spot on. Now, this was a board I asked PCB Way to make for me because it was small, fiddly, and frankly the components on here were so tiny that I didn't know if I was going to be able to solder them or not. Look at that crystal Y1 down there. I mean, that is absolutely tiny. I'm not sure I could have soldered that, so it's just as well PCB Way did an absolutely outstanding job on here. Why don't you have a look at their website and try them out now? Okay, that's the PCB thing that I will be doing. Back to the volume control then. So Amazon said, hey, look, there's a USB volume control here. Rather smart, rather nice. You just plug it in. You don't need to do anything. It just automatically sorts itself out. I've absolutely no idea whether this will work in Mac or Linux. Possibly. You'll have to go onto the Amazon. I'll put an Amazon link down the bottom, okay? You can have a look at it. And for £20, I thought, I don't know, it's quite a lot of money for a volume control, but do you know what? I'm bored. I'm at home a lot. You know, it's just, let's just spend the money, because I'm not spending it on coffees anymore, okay? And that's probably about, what, 6-7 coffees? Well, I don't know, a coffee is probably $2.50. So, well, yeah, without the cream and marshmallows, yeah, I know that. So anyway, it's a number of coffees that I haven't spent, so I bought it. So I plugged it all in. Windows said, yeah, I'm just setting this device up. And I can't remember what name it gave it now, but anyway, it took a minute before it goes, hey, we're all set up and ready to go. And I go, great. And the instant I picked it up and then turned this knob, I thought, this isn't a volume control at all, is it? It's a rotary encoder. Oh no, a rotary encoder on Windows. I could have done that because, let me just show you this device here, which I've had for a number of years. Oh, this, let's go back to the main one. Right, thank you. This is my video switcher. Yeah, I know I haven't touched it since the day I built it. And I said I was going to smarten it all up, but you know how these things are. This is what I use to switch cameras and things. So I can take myself off by pressing that and back on again. And this goes to the, well, that goes to the code window, that goes to the browser window, that goes to the window, the main window. And it all works as intended. And it uses inside here, apart from this capacitive touch sensor, which I did a whole video on about, it uses an Arduino, but not an Uno. It uses a Leonardo, because the Leonardo is not a 328P. It is in fact a 32U4 chip, which you might have just spotted actually in the browser there. Yeah, there it is, look. So it's a 32U4, but we'll come on to that in a minute, because as soon as I turned this and realised what it was, I thought, oh, I could have made that, but could I have made it so nice? Probably not. And it's got a little LED underneath as well. But I thought, do you know what? I could have made it, and people perhaps don't want to spend 20 quid, no matter how nice it looks. Could we make it, and how easy would it be to make it? And the answer is, a beginner can do this. So if you're a beginner, and you think, I don't really know much about Arduino code and all the rest of it, don't worry. This is simple, and I've given you two, not one, but two ways of coding this, just because I could really. One uses a library, one doesn't, or rather it uses the library but a standard Arduino library, and it works. Now let me play you a little bit of music first. This is royalty-free YouTube music, which I'm allowed to play. Woohoo. And I'll just twiddle this up and down. What I'm actually going to do is mute the microphone while I do it, because otherwise that will pick it up as well. So let's get the thing started. Right, that's started. I'm going to mute the mic. Okay, I won't leave it running in the background for too long because it's quite distracting when that happens. But you can see it's it goes down when you twiddle it to the left and goes all the way up when you turn it to the right. Okay, all very good and sensible. Also, if you press the button, mute, ta-da! So you can quickly mute something, and if you press it again, then it unmutes it because it's like a toggle. There we are, and back again. There's one little tiny additional thing on it. If you press and hold, so it's not muted yet, it's only muted when you lift your finger off, but you can now turn it up and down, and it increases and decreases the volume much more quickly than it would normally do if you hadn't pressed it. And then of course when you let go, it doesn't mute because it realised that you were turning the thing. Okay, so as a nice piece of equipment, and I really do like this, for 20 quid I think, yeah, that's all right. I'm happy with that, and it does exactly what I wanted, which makes me wonder what I'm going to use that for. But I've already decided that's going to be the volume control for my Amazon Echo unit that constantly seems to adjust its volume. It's via Bluetooth into my computer, you see, via the line in. So I'll be using that for that. So, how can we translate this into an Arduino bit of equipment? And it's so simple, it really is. Stand by. Let me shift all this off the desk and bring this thing behind here into play. Oh, silence, thank goodness. Sorry about that, it was a bit loud, wasn't it? Okay, now what we've got here then is an Arduino Micro. Now this is the official Arduino Micro. It's, well, first of all, it's quite expensive. I looked it up yesterday. It was 18 euros. They still make them. 18 euros. That's to me, that's a lot of money for what it is. You can normally get these. This is a Pro Micro. Now, this is a 5-volt version. You can also get a 3.3 volt version. And these, well, they're a lot smaller. Let's take it out and have a look. They're a lot smaller. They still have a USB socket, but no reset button, I notice. That's a little bit odd, isn't it? No reset. Now, there it is. Look, it's nice and small. And as I say, it's got a 32U4 processor on it, not the 328. You can't really use a 328 to send commands up the wire to Windows. But that's the little tiny one that most people would buy, and what you saw in a very quick preview on my browser. So I haven't wired that one up yet. I've only just got it out of the packet, in fact. So we're using the official Arduino Micro here, but it's exactly the same, apart from that, this has got a reset button on it. And I've wired it up with a rotary encoder. Okay, so that's just a rotary encoder, goes all the way around and back again. And I've done a couple of videos now on rotary encoders, how they work and what they do. I'll have a little recap when we get to that point. There's a different type of rotary encoder there. We'll talk about that. And, well, for the first sketch, you're going to have to look at the Windows desktop that I've got, because there's a little utility that I use, and that's how it sort of struck me how I could do it initially. Now, as you know, you can send commands up the USB wire from a 3 to U4, as I did in this mixer thing. So the way I control my screen videos when I'm doing it, like now, you know, to take me off and on, so it's suddenly not working. It stopped working. I don't know. I must have done something. Perhaps I've pulled something out. Anyway, the point is, what I'm sending up and down the wire to do all this stuff is keys, characters that I've told it to send. So I've said, I'm making this up, but I might have said Control X to turn me off, Control T to turn the picture back on again, okay, for these two, and ditto for each one of these. I'll probably use letters that correspond to what the function is, but basically that's what it is. It might be Alt Control as well, something that you're not going to use in Windows normally. A little switch on there actually to turn it off, otherwise this stays on. And I've uploaded various sketches to this over the years that I never intended to upload to it because I picked the wrong COM port. So I put a switch on here in the early days very, very quickly. Otherwise, so it doesn't appear in my COM port list. Yeah, that's very useful. So we can send various control characters up. Well, that's, if you heard that noise, that's just Windows enumerating this. And the normal characters, you know, A, B, C, D, 1, 2, 3, 4, they're just a dot. It acts like a keyboard. In fact, that's what the library's called, keyboard, keyboard.h from the Arduino world. And you can also send things like, oh, hello, where have I gone? Come back, there we are. You can also send things like left control, left alt, right alt, and key, you know, function keys like that you send together. So basically what you're saying to Windows is, I'm holding the control key down and pressing X at the same time, and Windows goes, oh right, okay, I've understood what you've sent me now, this sort of combination. It's actually called a report that you're sending to Windows, and there's a number of keys. I can't remember how many. I think it's like 6 you can send at any one time. So Alt, Control, Shift, T, that's 4. I don't know what the others are. Anyway, you can send all these combinations through, and they're, you know, you use them for shortcuts all the time. And indeed, that's what I'm doing for, well, both this and this in the first sketch at least. So before we look at the first sketch, I've just got to show you a little utility that I'm using. For this I need to show you the desktop so you can see it actually running on there. Right, okay, the volume control thing you now see on screen is indeed the volume control that sort of appears when the volume changes, courtesy of 3RVX. So if I change this volume via the standard USB volume control here, you see it goes down, okay, to nothing, and then comes all the way back up again. And I'm seeing that on my monitor as well. It's a little bit laggy at the minute. I think I've confused it a little bit. Anyway, but and this one here, which is our little 32U4 Arduino Micro, if I turn that also goes down and up as well. In fact, that's a little bit quicker, would you believe? Okay, so that's all working good, isn't it? I mean, that proves that it works, but how have I got it to work? Well, let's take this package away. If I bring up the 3RVX settings, you'll see how I've how I've leveraged the power of a Windows app to my own needs. That's the expression I needed. Right, so these are the settings for 3RVX. In fact, I can make those a little bit bigger actually. There we are. So if we start off at the General tab, I'm not going to run through each of these. You can download the app if you want and do with it what you want. But there's the on-screen settings. So you can, it will pop up when you have volumes and the keyboard, and you can even have brightness, which doesn't affect me because I'm on a PC, not a laptop, and eject. I haven't got a CD player on here either. But the thing we're interested in are the hotkeys. Now these are the hotkeys that you can set yourself. You can just say yes for volume up, for example, I want these particular hotkeys, and you just change them. And these are the ones that I just happen to have set years ago. I've been using this device for years and years and years. And you just type in your you type in your key presses that you want it to be. You could literally have A, but then of course every time you pressed A on a normal keyboard, it would increase the volume, not what you want. So you want to choose something that's unlikely to be used. And as you can see here, I've got Alt, Control, and the numeric keypad plus sign, which sort of, it's logical, isn't it? Alt, Control, plus, and then Alt, Control, minus to decrease it, and then Alt, Control, star to mute it, which I only added yesterday as I was doing this whole thing. So, and the mute incidentally is a toggle. If it's already muted, it'll become unmuted, and so on. And that's shown if I press the switch on here. If you look at that volume control down the bottom, so this thing here, now it just goes off. And press it again, it comes on. So that's how I've managed to get the key presses recognized, if you like, by Windows. There is of course another way, and I'll come on to that in a little while. But this is an easy way to get the key presses recognized by Windows. And of course you can change these values here to anything you like. If you wanted Control Shift B or something that's not used by Windows, that would work exactly the same. So I'll leave links to 3RVX down below, and you can download that if you want. Right, that's enough about that. Let's have a look how the code, the Arduino sketch, now talks to, well, effectively Windows, and then ultimately via this app to get that volume changed. Now I'm actually just recompiling this to put the debugging back on, otherwise you'll see nothing in this window here. You must switch that debugging off, i.e. all serial.print type statements, because it's an Arduino Leonardo at the end of the day, and it'll always try and communicate with your PC to say, I've got something to tell you, and it'll wait until it times out, so everything will be in slow motion. Yeah, very annoying. So you've got to switch it off. Anyway, we'll come on to that. Has it done it? Has it actually done it? Verifying. Right, it says it's done it. So let me just connect a few buttons here just to say go. Right, there we are. Starts. So that means if I touch, so what I'm going to touch, just so you know what I'm doing, I'm fiddling about with this potential. It's not a pot, it's a rotary encoder. Okay, that's what I'm touching. So if I turn it left, now look, D for down, so it goes down and up. In fact, if I bring that volume control on, it would help, wouldn't it? So you can see what I'm doing. Right, there we are. So now if I press down and up, see that? And if I press the button on it to mute it, it says muted. And if I press it again, it says unmuted. Great. So that's the demo. All done and dusted. End of video, isn't it? No, not quite. Okay, let's just walk through it. There's a lot of stuff up here where I've said I've had some help on the internet. There's some this guy here who does the 3RVX thing itself, and the keypad values that I found from the, because what I couldn't find was how to do the numeric keypad signs. It's all right doing the standard keyboard ones, they're all documented on the Arduino documentation, but the specific ones on the numeric keypad, plus minus, I was having trouble finding those out. So this chap here, John Wasser from the States, he's given all these keys out, and that's what worked just fine. So let's look at the code then, okay? Top line you can forget, that's just the header file for this sketch and I'm not using it. You can forget the Arduino as well, that's just the IDE I'm using. So the first one we really need to look at is the keyboard.h. That's a standard Arduino IDE library that you can use. That's my debug, so it stops the serial output when you compile it with that commented out, otherwise things go into slow motion. I'm defining the two keys, so on here I'm using pins 2 and 3. Originally I used pin 2 because that's an interrupt pin, and that's how perhaps you'd normally use a rotary encoder, but for this sketch I thought, you know what, I've done so many rotary encoder sketches with interrupts, I'm just going to use it in a loop now because we don't need an interrupt. This sketch is not doing anything else, its prime purpose is to look at this volume control, so it might as well whiz round in a loop just checking to see what's been turned and pressed and whatever. Okay, so interrupts where they're needed, but not in this case. Okay, a few things here. Oh yeah, and the mute pin I've set is 11, it's just one I picked at random. A few variables just to track the state. This is the bit here. In fact, all this in here. This is the bit about taking off that serial output. If you use it this way, this is a compiler directory, so it's not runtime code. This if defined debug, that's the thing we had at the top of the sketch. If it's not defined, you've commented out, all this code in here will not be compiled. It will just be removed from your sketch, which is exactly what you want, because you don't want any serial output when you're normally running this. I've only got this in here, A, for debugging, and B, so that you can see what's going on over here. Okay, right, so a couple of pin modes. They're both inputs. You don't need input pull-up because the rotary encoder already had its power supply. It's got a plus and minus VCC and ground going to it, so you don't need that. The switch, however, you do, because the switch goes to ground. It's grounded, but you need something on that switch initially, so it's input pull-up. And then, of course, we have the keyboard library object, keyboard begin. I think all that does is release all the keys and just make sure nothing's pressed at the time. And in the loop, then, the first thing it says is, am I pressing that button on there to mute it? But it doesn't actually mute it until you let go, and just sets a flag. And then it says, basically, you can look at this logic of this in your own time, but basically what it's saying is the rotary encoder being turned? Now, I'm using pin A as my primary output from that rotary encoder. It's only got two, A and B. They're marked up like that by convention, really, even though on that rotary encoder it doesn't say that. It says something like clock and DIO, data in out, I suppose, I don't know, but normally it's pin A, pin B. So what happens, in case you're not familiar with rotary encoders, and there's a whole video on this, it explains it to the nth degree. Let me just give you a 1 minute, literally a 60-second primer, and if you already know about this, skip ahead 60 seconds. Right, this is a very brief overview on how a rotary encoder works. On it, it's got two switches, which we're going to label pin A and pin B. All right, and they go from high to low as you turn it. All right, and the two sets of switches or detents in them are 90 degrees out of phase, as you can see. They overlap basically, and the logic of it is that if the detent, with the natural resting position of the spindle is in the middle of this high, as you turn it and it moves off that, it then drops, at which point your sketch can say, oh, there's been a change on pin A. What is pin B doing? And pin B goes, well, I'm high at the moment. I've got plus 5 volts on me. And the logic is, we must be turning now in a clockwise fashion. So great, your sketch says I'm turning clockwise. I'll wait now until you go back up high, get back to that detent and wait. Okay, and then the same thing happens. You move off the detent down to low. It says, yes, pin B is high and must still be moving in a clockwise direction. Great, do what you need to do. In this case, of course, increase the volume. What if you were going the other way, though? How does it work? Well, let's start at this end, just to make it easier. So we're resting in the detent here. Was high, drops to low. It goes, what's pin B doing? Oh, look, pin B is low. That means we must be moving in an anti-clockwise direction. Great, okay. I'll do what I need to do and wait for pin A to move along here and back up high and rest back here and start again. So that's how it is. Anti-clockwise moves that way, clockwise moves that way, and it depends on the value of pin B at the time, whether it's high or low, that determines the direction. Simple, genius, and I wish I'd invented it. Right, you're back. So what it says is, okay, you've started to turn that command, and I've detected which direction you're going in by the value of the other pin that's out of phase. So I know which way you're going round, and therefore can issue these sort of commands. So what we're saying is keyboard press, and we're saying left Alt and left Control together. It's like holding Control Alt down, and I'm pressing this funny value, which just happens to be the numeric keypad plus. Right, so Control Alt plus as a 3-key sequence. Windows accepts that and go, oh yeah, I know what that means. Or at least I know what you've sent me. Who's interested in this? Because I'm not. Windows itself is not interested in that combination. It says, I've got no shortcuts that do anything like that. Anybody else? And of course, 3VRX steps in and goes, well, yeah, that's one of my shortcuts. I'll have that, thanks. And then does its business and ups the volume. You have a small delay here. It's only 100 milliseconds. And then we say, now release all the keys at the same time. Bang. You can release each key individually, but there's no point. Might as well say, release them all. And then the next bit says, if I'm actually pressing that mute button at the same time as doing all this, just go and do the whole thing again. And I know this coding isn't very concise because I'm coding this bit here, you can see, exactly the same as I'm coding here. So normally you'd put that into a little function, so you only write it once. But for demo purposes, I've written it twice just so you can see what's going on rather than multiple calls out to some function somewhere that's not clear. So that bit you're seeing on screen now is in fact the essence of everything else, because that's the up volume. Then there's a down volume, which is that one there, exactly the same, except there's a different value. The keypad key I'm pressing is now the minus, not the plus. That's a slightly different value. Thanks to John Wasser giving us that. And what else? Yes, we wait. Now this is the interesting bit. As you're turning the rotary encoder, so if you like, the pin A has gone from high to low. So this program sprung into action and go, whoa, things have changed. I'm doing stuff now. It's now got to wait until you've turned it enough to the next detent. So it sort of clicks into place all the way around. So it goes high again. It goes, you've gone high again. Now I'll just carry on with the sketch and wait for that pin A to change again. Otherwise, you're going to get some very funny results. Believe me, I know. What else does it say? It says, yes, here it says, was the mute pressed? You've pressed it down. Do I need to do anything? If so, I'll mute, and that's the key press to do it. That's the numeric pad ** key. If it's ignored, the flag for that is no, we've been doing the volume control with that thing pressed. You don't need to do any muting, and that's how that's set. Okay, that's set a little bit higher up. I'll let you read it, and that's it. There we have it. It's ended. I mean, so really, it's 3 key presses. Some of them duplicated because we're pressing the mute key in to make it go faster up and down, and that's it. Yeah. So now that you've seen the code and you've seen the output window over here, you'll see exactly how this works. Look, it's just simplicity itself, isn't it? An ideal for a beginner. Oh yeah, let me share that. So if I'm pressing down and I press the mute button in, so I've pressed it in and I'm turning, look, you see you get the D2 now. That's the second down. So for every little tiny press I do, I get a down and then another down. And when I let go, okay, it shouldn't have said muted. It's probably because I'm playing about. Ditto, press it down and go up. You get an up and then another up, all on that one little tiny thing. Okay. Yep, it didn't mute when I let it go that time. That's how it should be. Okay, so that's it. I mean, that's so easy, isn't it? But it does leverage 3RVX app on my PC, which is the first way I was going to do it. And then I was thinking, how does the bit I bought, how does that do it then? Because that doesn't rely on 3RVX, and that took a little bit of digging, to be quite honest. I tried it with various values on that keyboard thing, and it wasn't too successful, but eventually I got there. Let's have a look at the sketch for that very quickly. Right, this is the second sketch then that doesn't use the keyboard library from the standard Arduino core. This uses a different library, as it shows you here. Now this is from Nico. I don't know if his name's Nico Hood, as in Hood is his surname, or I don't know, but anyway, he calls himself Nico Hood. And the library I'm actually using is HID project. There's a load of stuff he's got on his GitHub, and they're all sort of intertwined a little bit, but I've just pulled out this HID project, and what that allows is for you to send the actual volume down and up commands and the mute without anything else, and Windows understands that directly. So now you're talking to Windows, not 3RVX. So that sort of stops you having to load up 3RVX if you don't like that on-screen display. You just want the standard old Windows rubbishy thing. So, and in every other respect, really, this is working identically. The main difference is that we're having consumer here, not keyboard, because he doesn't use keyboard. Though he does have a keyboard object as well, but we're not using it. And in the loop, the code, I think, is identical, apart from here, look. Whereas we had 3 lines, we said press the Alt key. press the control key and press the numeric plus key to make the volume go up. Here you just say turn it up, and he's done the bit behind the scenes to get that volume up value, which is in fact 233, up to Windows in a controlled manner, so he knows what multiples of keys he has to press, and it just works, and everything else is the same. So if you don't want the 3VRX app on your Windows machine, or you've got a Mac or something and it wouldn't work anyway, I don't think so, this might work instead. I'll let you read the documentation for that though. There'll be links below the video for all of this, but the sketches are virtually identical, deliberately done that way obviously to show you the two different ways of writing it. Yeah, I think that's probably about it really for the code. Let's have a look at where you can buy the micros and whatnot. Right, so this is something I found on the UK eBay site. Just be wary though when you buy stuff like this, because look, it says Pro Micro 80 mega 32U4, yes, 3.3 volts. Well, you don't want 3.3, you really want 5 for this. It might work on 3.3 because the only thing you're connecting it to is that rotary encoder, but I'd stick with the 5. And it says replace 80 mega 328p Arduino Pro Mini. No, the Pro Mini, as it rightly says, is a 328. Well, it doesn't replace that. It's totally different kettle of fish altogether. So make sure that what you're buying is a proper Pro Micro or Arduino Micro, but the Arduino Micro is expensive. Looking at Banggood, here we are, $4.49 it is. Is that free shipping? Yes. No, it's not. Ooh, $2.31 shipping. I think Banggood, in fact, a lot of the Chinese vendors I know have put shipping up to some sort of minimum now due to the coronavirus situation, just to get this stuff to us because the standard post is taking so long. So they don't even give us an option anymore. No, you see, look, it's priority mail or EU priority, which is even more expensive. But of course, we're not part of the EU anymore. So yeah. So $4.49 plus that shipping cost of $2.31, which is quite a bit. But oh, you can buy it from the UK. So if you are in the UK, how much does it cost? It costs $7.48 with free shipping. So that's probably about what, a $5, something like that. It's probably better value you get it in the UK if you're living in the UK, because it will get to you real quick as well. Let's have a look at AliExpress. All right, well, they're doing it from 378 to 398. So what's that? That's the 5 volt version. That's the one we want, actually. There we are, look, 378. It's just, oh, free shipping. So actually, AliExpress is cheaper. Mind you, free shipping, though. Let's just have a look at that. Yeah, my concern here is that, look, none of these are tracked. No tracking, no tracking, no tracking, until we get to here. And then it's $2.71 to get it tracked. It's still 15 to 60 days, good Lord. Yeah, I normally go for tracked stuff. Otherwise, you could be waiting forever and it's disappeared off the side of a ship somewhere, never to be seen again. So, it looks cheaper initially, but I'm not convinced it is anymore. And, oh yeah, rotary encoders, they're cheap. This is AliExpress again. You can say the 157, 192, plus whatever shipping charge it shows here. And that will probably differ for the country you're in. Make sure you get, I would say spend a little bit more on the rotary encoder if you can, rather than get the cheapest of the cheap. There's quite a few here, as you can see, and I don't know the difference between them. But you might want to look locally just to see how much they are. See if you can get a Bourns one, B-O-U-R-N-S. They're very good. Although the one I've got here, as I say, it's a cheap one. And it works well as any other. But of course, you never quite know what you're getting on there, do you? But this one does seem to work quite nicely. Yeah, I've got no complaints about that. Now, talking of detented or stepped rotary encoders, so this, as I move this goes into a definite step. You can feel it, right? It's ratcheting up, like the mouse wheel you've got, where you can have it, ratcheting up. And yeah, that's fine. It's got a definite position. But this one is stepless, and you don't know where you are. And I'm just wondering how that would be used in a state like this, because you can never actually move from one position to the next without it getting confused halfway through. I did do a video on stepless, and I think I said at the time I was less than impressed. And It hasn't even got a switch function. Look, you can't press it down. There's nothing to press. It's only got 3 connections. So it's probably plus, ground, and signal out. Or possibly even ground and the 2 pins, actually. You've got to have 2 pins, pin A, pin A, pin B, and ground. Bit weird, isn't it? Don't go for stepless. It's not suitable for this type of project, in my view. Some people like them, not me in this case, though. Right. What else was there for this project? Nothing really. It's just the micro, one rotary encoder, and you're done. And you can make effectively the equivalent of this for probably what, 3, 4, 5, 6, well, less than £10, so half price. But of course, you still got to get a nice potentiometer knob or something, haven't you? Right? Well, you could use something like this, I suppose. They're 10 a penny, and a case, but you could use a plastic case. Personally, I think the extra tenner that I spent on a nice solid, it's quite weighty, this case as well. It's got little feet underneath. Let's stop it scratching. I think actually, if I was making this, having designed it now, if I said to some, I don't know, R&D guys or whatever, I say, look, I've designed this, go and make a proper product out of it now, they'd probably come back with something like this and go, we've got to sell it for 20 quid in order to make a profit on this. So I don't think I was hard done by with that at all, and it works like a dream, as you can see. Anyway, links down below for all the things we've talked about, including the video on the rotary encoder that I did that explains it all in the nth detail. And once you've understood that, the light bulb goes on. You go, oh, that's clever. I wonder who thought of that. Yeah, I wish I had, believe me. Okay, thanks very much. If you like the video, do give me a thumbs up, and see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.